Hello, first of all, very good morning to all. I am Priti Choudhary and I am assistant professor in Ajay Kumar Garg Engineering College from IT department. So today I will discuss about queue in data structure. In my previous lecture, I have discussed about what is data structure, means introduction of data structure, types of data structure. So from last session, I have discussed different types of data structure, means give a brief introduction: array, linked list, queue, stack, tree, and graph. So now in this lecture I will discuss about the queue. What is queue, and what is the main application of queue, and why we use this queue in data structure and real world, and what the application types of DQ. These are the some uses in queue. So first one is queue. Queue is contain the element of same arranged in a sequential order. Means it is also the part of linear data structure. Means in my previous lecture, I have discussed about the data structure divided into the two parts. First one is linear and second one is non-linear. In linear data structure, use array, linked list, stack, queue, and these are the some linear and non-linear. In non-linear data structure, use tree and graph. Tree and graph. So in this lecture, I will discuss about this data structure. So it is also the part of linear data structure. Queue is the content of element of same arranged in sequential order. Means here we use the same order. So operation in take place in the both, and insertion is done and deletion at the front. Means queue look like this. Here it is work on FIFO, means first in, first out. It is work on this principle, FIFO. So here indexing is given 0, 1, 2, 3, and this part is called front, and this part is called rear. Means at the end of queue is called the rear, at the front of called the front part. So it is work on the this principle. So a queue is defined the linear data structure as I discussed, and the element which is the push in the order, and operation is performed on that in different mode. So what is the ADT? ADT of queue. ADT is the abstraction data types, means different types of operation performed on queue. So first one is NQ. NQ is what? NQ is the operation where we want to insert any element at the end of queue. You want to insert any element. DQ. DQ operation means remove any element, return the first element of queue if it is not empty. Peak. Peak return the last element. When last element would you want to remove from queue, that element return by peak operation. Size. Size return the number of element in a queue. Is empty. Return true. Return true if queue is empty. Means no element is in queue. Then is empty operation return true. Is full operation return true if queue is full, otherwise return false. Means if any element present in queue, then return false, otherwise it return full, true. So first operation is this NQ. NQ. NQ is used when you want to insert an element in your queue. So there are the some steps using to in NQ. So these are this according to this is the queue, and here first element is A, second element is B, and third element is D. So according to this queue, it is your front part, means it is your front part, and last element of queue is called a rear part. Now you want to insert any other number, any other element by NQ operation. So like this, you want to insert D in this, in here. So here, this is the enter this queue easily because it is work on FIFO. So it is a now. So now it is a rear. Rear indicate the C right now, but after insert this element, rear is increased by 1. R plus 1. Now rear is indicate D, and front is same because there is no any change. But front is change when if you want to remove or delete. So these are the some steps. According to first step, check if the queue is full. First is check, means you define the size. Firstly, you define a size in queue, like your size is 4. Size is 4 of queue, and so according to indexing 1, 2, 3, and your number is A, B, C, D. Now you want to insert here another element F. So according to this queue, written queue is full, means underflow. You cannot enter, you cannot insert F in the queue because you already define your size of queue. So second is if queue is full, then produce the overflow condition. In this case, when your queue is full, then produce overflow and exist. Otherwise, if you have some means your size is 5, means here one space is also left, then you want to insert F, so then you can easily insert. But here according to this case, it is front and it is rear, and now you want to insert another element F here. So increment R plus 1. So this is your R indicate right now. Okay, got it. So add the data element in queue location where the rear is pointing. So here the rear is point here D. Now your element insert there and return success. So this is the NQ steps when you want to insert any element in your queue. And the implementation of queue in C programming language and how it is used. First of all, create a function like this, and NQ it is the integer types of different types of data. So you want to insert as an integer value. So check here if n equal to means rear equal to n size or rear equal to n minus 1. If you take indexing start 0, then r equal to r minus 1. When if you indexing start 1, then r take equal to n. Then this condition when this case is occur, then this function is follow is full and return 0. Otherwise, then this condition is apply. Rear equal to rear plus 1, and at the end of rear add your data and return 1. So this is the NQ operation in implementing in C language. Now second operation and second entity of Q is DQ. So DQ is what? Accessing the data from, means if you want to remove any data from Q. So here you remove your data into process of two tasks. Access the data where front is pointing and remove the data after accesses. So the following steps are taken to perform the DQ operation. First one is check. Means if you have this according to this is a queue. So it is a queue. Here some element is include A, B, C and D. Means you want to remove, you want to delete any element from this. So you want to delete from first, that is front side. So it is work on FIFO. So it is first come, then it is also out first. So you want to front remove. So firstly check if the queue is empty. No, according to this, queue is not empty. And if the queue is empty, then produce the underflow condition according to this case. This case indexing is 0, 1, 2, 3 and it is your front, and it is your front and also uh, not front. F and R both in this case equal to -1. So there is no any element. So according to this, there is no element, and now you want to apply DQ operation on this queue. Then what condition is occur? Then produce the underflow condition and exist, because there is no any element to remove here. So here front and rear both are placed -1. So means no element in this queue. So you cannot remove any element from this. So but condition is this. Second means there is some element in your queue. Now you want to remove your element. So it is work on front side, because it is work on which principle? FIFO principle. So according to this, it is remove from this side. So here now remove this. A is outside from the queue. Now front is increase, front plus 1. Now front indicate is B part. So got it? Now again the implementation of DQ operation in C implementation, C programming language. So same is this. Again DQ is operation and apply is empty. Empty is what condition? What will the condition occur according to this case? So return 0. Otherwise means you have some element in your queue. Second case. So according to this queue, front and data remove, and front is front plus 1 and return your data, which data you want to delete from queue. Now third operation is peek operation. Means peek operation is the last element show in a stack, but according to this, peek element used for last removing element. Means according to this, you have according to this 1, 2, 3. So A, B, C and D, and according to this, it is your front and it is your rear. So now you apply peek operation. So what the output is? Last removing element. Last element. So removing element is where use FIFO condition, means A. So output is A. Just use so. Just display your last removing element, not actually delete. So this is the in element remove, return, Q, front. So front is what? A right now. Is full means when your queue is totally full, means no space is left. Insert any element in your queue, means you defined in your queue size is 5. 1, 2, 3, 0. Size is 5. You define queue size. So 0, 1, 2, 3, 4. Or this number is already all number is filled. A, B, C, D and E. So means all element fill in this queue are according to size. Now you want to insert another element F, but size is only 5. So you cannot insert this. So that time your condition is full. So check. Firstly, it is check what? Size Q means rear. So it is your front and it is your rear. So check कि rear equal to what? Max size is n minus 1 means 4. N minus 1 equal to 4. Equal to 4 means yes. So return true, otherwise return false. Is true means Q is full. Q is full. Got it? Now is empty. Check. Same. If your front and rear both equal to 0, yeah, we can say that the minus 1 means here, and size is again 5, 0, 1, 2, 3, 4. So it is the your Q. Now you want check it empty or not. Means here no front and rear. So according to this, front and rear both is minus 1. So check if front is less than 0. Less than 0 and rear is greater than less than front. Means both is minus 1. Then return is true. Otherwise return is false. Now representations of Q. There are the two types of representation in Q. First one is using array and second one is using linked list. So first of all, I will show you what the representation mainly used in according to Q. So there can be different way implementation and ADT. Q ADT can be implementation using array or linked list. Okay. So according to this, it is your Q. Also Q is this, and there the some element you already insert in this Q. So what is the front and what is end? The front is the first element when you want to insert. So this is a 3. 3 is inserted first time. So it is your front and also called a head when you use it as a linked list. And it is last element. Last element is what here? According to 8. 8 is a rear. Now you apply in both operation here NQ and DQ. So NQ use at the rear means NQ use at a insert. Use insert element. Insert element NQ. And DQ use for remove element, delete. ठीक है? Delete element. So if you want to insert, then apply NQ operation. If you want to delete, means 2, 3, 4, then apply DQ. These are the operation performed on this Q. Now that comes to the time complexity. Time complexity is a big notation. So according to space and according to searching, according to insert and according to delete. According to space, time complexity order of n means order of n, the number of element is already insert in your Q. So space, according to space, time complexity is order of n. Searching is also comes order of n, because you want to insert your number in a Q. In a best case, you can easily in your best case you find out your number at a first position, but your number is at the end, otherwise not present in your Q. Then that time your complexity is order of n. Insert and delete both time complexity is same, order of 1, means insert any single element and delete also any single element. So in this case we use the order of 1 and 1 order of 1 time complexity insert and deletion. Now principle of Q, same thing. Principle mean, as I discussed in my previous slide, so Q is like a line waiting a purchase a ticket where the first person in a line in a first person serve, means FIFO operation, first come first serve. So according to this, same things is here for this. If you want to this is according to this Q 0, 1 to this indexing, and if you want to insert this is if you want to insert, so insert is here the end, at the end if you want to remove, so this is, so it is your front, so according to this is your rear. Front means first come, then this come, then this, after this, after this, after this, when it comes to after one by one. So remove what? So firstly remove this front side. The front side is 40 remove as a first, then 30, then 20, then 15, then 10. So it is work on a FIFO, first come first serve. Application of queue. Application of queue. Queue is used when things don't have be processed immediately, but have to process is a first in first. So it is used in data structure. This algorithm, breadth first search, means it is used as a. I will discuss this algo in tree data structure. So in the tree data structure, we use the first breadth first search, BFS. BFS work on queue principle. So this property of queue make it also useful the following kind of scenario. First is this, it is used the different types of scheduling in operating system, CPU scheduling, disk scheduling and all. And when you data transfer asynchronously and data is not necessarily received at a rate between, so these are the some example is used in a queue. Now implementation of queue, as I discussed in my previous slide, the implementation of queue is two types. First one is array and second one is linked list. So array is simple, you define your size first and like this, okay. According to this, if your size is 1, 2, 2, 3, means size is your 4. Okay, size of for array 4 and A, B, C and D. Now all operation apply on this, means and Q, DQ, peak is full, is empty. Means these all operation apply using array. But if you want to implement this queue using linked list, then what is the representation is this? A, B, C, D. It is the link to second, again link to the next node, or it is your null. So we take the size is 0, 1, not size 100, 101, 102 and 103. So according to this, it is your head part and it shows the first node address. Okay, so according to this is the linked list representations. Now same thing is this implementation of queue, same thing. So we can easily represent the queue using the linear array. There are the two variable front end and rear, both is included here, and same like this here again same thing, it is your front and it is your rear. Okay, so we can easily represent queue by using linear array. They are the two variable front and rear that are implemented in a case of every queue. So these two are the implemented in a case of every queue. Every queue and front and rear variable front of the position from the where insertion and deletion are performed in a queue. Initially, the value of front and DQ is represent the empty of queue. So according to this, it is your array representation. In array representation, you insert some element. So indexing is given according to this 0, 1, 2, this 3, 4, and these are the element include insert in this queue. So according to this, it is your first element when you insert this first time. So it is front side, and this is your last element insert in your queue, that is called a rear. So front side right now front is pointing is 0 indexing and rear is pointing is a 4. So now apply the different operation. So insert from the rear, because NQ is where NQ operation apply insert. and insert मतलब insert from rear. So according to this, if you want to insert G like this, if you want to insert G, because in previous Q this space is left, so now you want to insert a G. The G is insert is where? Rear, at the rear. A rear is pointing here according to this. In my previous slide, this is the rear. Now it is increased by 1. Now rear pointing the this point is 5. So got it? And front is not changed, because when it is changed, when you apply DQ operation. When you apply this Q DQ operation, then front pointing is changed. Then front is front plus 1. But in this case, front is not changed. Only rear case is changed. Same this. Now front is now delete from front. So means according to this, there are restrictions to delete from a front in a Q. Now you want to delete first element. So first element is what? H. So H is now the front is indicate the 0 indexing. Now you want to delete H because it is come first. So H is removed. Now front is in a previous case front is indicate H means indexing 0. But now this case front is front plus 1. Now front is indicate 1. Means but rear is not changed. So in a deletion case, rear is not changed, but in a insertion case, front is not changed. Now some algorithm in NQ. NQ means insertion. If you want to insert any element in your Q, then you apply NQ. So algorithm for NQ is this. Check. First is the check is this. Insert. You want to insert in any element in your Q. Then there is a different types of scenario. Now you check one by one. First scenario is this, ki if you want to insert any element but your Q already full, then you cannot insert. So first case is this, if rear means according to this algo, according to this line, sorry, means size is 4. Size is 4, A, B, C, D. Means now check rear. According to this, it is your front and it is your rear. So check rear equal to max minus 1. What is max? Max is 4. 4 minus 1. 4 minus 1 matlab 3. Means 3. So it means it is 3. So now check it. Max minus 1. Max minus means rear is 3. Yes, rear is 3. Means all element is filled in this Q. So it is indicate the this Q is overflow. Then go to last step, means if this you cannot insert, but means you have element size, you have some size, you have some space in your Q. Then check, means second condition is this. This second condition is if front equal to -1 and rear is means -1. What is this? It means front and rear both are -1. Means what is? Your Q is totally empty. No element in fill in this Q. So front or rear both is -1. So according to this, both is -1. Now you can insert your element is here, and now set front and rear both is 0. Otherwise you can this comes to this means add, means you have A, B, C, and now you want to insert any number, so you can easily insert here your fourth number, and now but changes is rear plus 1, or at the end of you can insert your number. So this is the algorithm of NQ. So in this lecture I will discuss about the what is Q and types of Q, application, implementation, and different types of operation, means NQ, DQ, peak, is empty or full, all conditions is discussed in this session. So and at the end I'd have discussed about the algorithm of NQ. So Now my next lecture I will discuss about the next topic, means algorithm of DQ, algorithm of peak, and is full and also implementation in C language, these all operations. So thank you so much.